Hello. My name is Sarah Honan and I am head of AD Demand, and thank you all so much for joining us for Flexing the Grid for a Decarbonised Future. I know it's been a long morning already and people will be coming in and out to have a little break. So just so you know, that's all fine. And to introduce this topic, I thought it would be useful to essentially lay the groundwork and why I'm probably the moderator of this panel. So I work for a company called AD Demand, which is a trade association focused on making sure that demand side assets are seen in an equal light to generation and networks, which I think we can all agree is not the current policy landscape. We need to make sure that every home, business and industrial site has an economically rational decarbonise, and making sure that demand side assets are seen as that, assets, not sites, is the way we go about that. So I'm incredibly excited about our panel today, and I'm going to open with introductions for each of them and for them. Sorry. It's a very strange sensation. For them to introduce their businesses and why they are on this panel for Flexing the Grid for a Decarbonised Future. I will maybe start at the end while we deal with sound issues.
Hi, I'm Stephen Todd. I'm the head of partnerships for E2 Energy Partners. We build private energy markets for industrial supply chain companies in the UK. So the reason we're on this panel is we are pushing renewables as hard as we can because we believe that's the right thing to do, and economically it's the right thing to do. But we're faced with a number of issues around intermittency and stuff. So the demand side management is really important to us to be able to deliver linear energy to coax people into the renewable movement rather than just getting an EDF brown energy contract.
Amazing. Denise?
Hi, everyone. I'm so excited to be here. My name is Denise Owusu. I'm a utility decarbonization manager. I actually started my career in oil and gas and then decided to get on the right side of history instead of being on the wrong one. So now working with utilities to help them reach all of their clean energy goals. I work for Motive Power. That's a utility consulting firm based out of California. I'm focused on all things capital project execution, data enablement, AI enablement. And then I also lead the National Public Utilities Council, which is our research and industry engagement arm that's focused on helping utilities reach their clean energy goals. Happy to be here.
Amazing.
Good afternoon, everybody. My name's John Swallow. I'm the managing director of a company called Test Consulting. We originally started our journey as an energy and carbon management consultancy. However, we've got a strong engineering background and we very much are now boots on the ground. We've worked on several large-scale delivery of renewable systems and have seen quite a few different challenges on our way through that pathway. So I'm here today to effectively maybe give you some of the stuff that might be happening on sites and then potentially some of the things that we might be able to do which makes it a little bit more coordinated and a little bit more reliable and certainly a lot more visible for customers and owners and asset management companies.
Thank you. My name is Matt Ursin, and I'm a senior director with Fastnet, which is a charge point operator providing ultra-rapid fast charging, public fast charging across Europe, including the UK. But I'm been invited here in my capacity as the chairman of GIGA, the Green Industrial Grids Association, which is a multi-sectoral organization that is focused on everything around the grid topic. But mainly on the demand side. Obviously, our organization includes various sectors, large electricity users, Google, Microsoft, Amazon, big tech, but also companies like mine and other industrial sectors as well.
Amazing. Thank you so much. And just so I'm abundantly clear, can I get a bit of a wave from people that sound is okay for everyone in the audience? Yes. Lovely. I feel like I'm at a Coldplay concert. So Also, just to let everyone know, we will be coming to audience questions for about half the session. So do be thinking things up as we go through the panel, and there'll be a roving mic to help you do that, or to help us hear you. So I think kind of going back to basics a bit, when we think about grid flexibility, we've never had to really worry about this before. We've never had to question it. It's always been a system based on dispatchable renewables. And so when we talk about grid flexibility going forward, we're often talking about the widespread expansion of electrification of industry, homes, businesses. The backbone of that being backed up by intermittent generation. So when we're thinking about electrification, what are the biggest kind of barriers and opportunities you're all seeing in your sectors for that at this time? Who wants to start?
I can go ahead. So I'll say, of course, coming from oil and gas and burning fossil fuels, electrification gives us an opportunity to get away from that. So we love that. We love not emitting greenhouse gases when we don't need to. So that's definitely the opportunity. I would say for the US, maybe where we have fallen short is just the planning for it. So typically utilities plan on a 10 to 15 year cycle. Electrification was something that we did see years ago, but I don't think we acted on it knowing like this for sure is going to happen. So there's been a little bit of a stall on kind of being able to set up the infrastructure to be prepared for all of that new demand. On top of the electrification demand, we also have the demand from AI and data centers as well. So it has been a very humbling experience as we try to squeeze 10 years of planning into 1.5 years.
Yes, and I think anyone with experience in UK connections queue can back that up. Who'd like to come in next?
Right, so we deal slightly more with industrial companies. So we look at it on slightly more micro scale than the grid macro scale. And I think the issue is that people are going to have to change their behaviour in the way that their operations work in order to use energy at their optimum times. And you're trying to convince a traditional facilities manager that's bought energy off EDF since Adam was a lad, it works. You turn the kettle on, you turn the machine on, it works. You're trying to say, do something different because it's the right thing to do and the economics will come into line. So the biggest challenge is you're talking about behavioural changes, and that's always difficult to try and install. And I think the biggest barrier is battery economics. And I think that will always be the biggest barrier until the EV cars make that cheaper. But that's a slight side issue. But for me, the biggest challenge we face on a more micro scale is you're trying to talk to industrial energy users about not working on a linear curve, about slightly adapting their business practices in certain circumstances. And that's a hard sell.
That's a super interesting one, and one I might like to come back to in terms of when we're thinking about flexibility for industrial and commercial users especially. Is the future actually about behavioural change, or is it about automation and making sure we have bespoke offerings to those companies?
I think it's a bit of both.
Yeah.
I know that's a bit of a political answer and I don't want to sit on the fence, but I think there's going to be times until we can put massive batteries in places, and that's well off in my opinion. There's going to be times when factories that deliver parts to OEMs have to work differently.
Yeah.
But I also think that DSR, demand side response, is really important. And again, you're trying to convince a 55-year-old facilities manager that's done the same thing since he started his job when he was 20. You're trying to say, mate, let's mix it up a bit. It makes it a difficult sell as someone on the sales side. So.
And on my side, it's trying to convince control room engineers to change their ways.
Let's not forget the engineer.
Yeah.
I think we've done well on ambition, but we've underinvested in the infrastructure and also on the delivery side of things. But I think inside the box, we've always got a client at the end of the chain. So I think the idea of some of the controls that are required is a different landscape and is very difficult to get across to most end users, which then potentially means that anything that they're having designed that might be fit for purpose from a point of view of it being electrically capable, it's not always twinned with what the demands of the actual physical client is. And therefore, then there might be a recipient at the other end, which is the grid, who can't do anything with it. So I think from my side, especially on that engineering side, it's more along the lines of visualizing things at high level, but being involved in more projects from the start. Often in our experience as it stands at the moment, we're at the end of the process. So we're left with a very difficult scenario insofar as something's being designed, it doesn't go down, it becomes a bottleneck, and then everyone's potentially upset. And I'm the bearer of bad news at that point. So I think that the idea is to make sure that if we've got an holistical approach to it, then that's fine. But then also as well, we need that flexibility to come back from the grid in terms of ensuring that any overspill is there, can be collected, so on and so forth. I've got a few more gripes about how that goes together, but we'll get into that later on, hopefully. But yeah, I think my view is more along the lines of trusted data, visibility of the assets, how they should work together in tandem, in triplicate, whatever way it should be, and potentially then looking at things like island mode and so on and so forth. So the engineering level is expectant, the delivery is undervalued, but then also as well, the solution is often wrong.
I think that goes to the point of a really important distinction, and we might get into data centres a bit later, is how do you set up industrial commercial sites as flexible that are built versus for trying to retrofit or electrify existing sites? And the challenges there are incredibly distinct. Do you want to come in?
Yes. Well, if I might take one step back, I think it is important to understand that our societies and industries are going through a major transformation. This is a very important moment in terms of transition, probably as important as Industrial Revolution in the end of 19th century. So the grid is the underlying infrastructure below that. So if we do not get this right, we will pay Europe a very heavy price in terms of our climate goals, of course, but also in terms of our economic power, of our competitiveness, or the future of jobs or industries. So if you ask me what is the biggest issue, obviously, I would say that the grids that we have in Europe have been built for another age, for another area, and they are not up to the task. So to come back to what Denise was saying, so we need to accelerate this transformation. We need to make sure that there is a commitment on the public side for it, that the regulated and policy side is right, has an understanding of the urgency, but we also need to make sure that we bring in the demand side into the discussion, into the planning especially, because so far the planning has been mainly done from a generation-led approach, whilst we need to have anticipatory planning, we need to understand, have a dialogue, have a system that includes demand side in planning. And also, last point, that's very important, I think, we need also to make sure that we unlock private capital investment, because there is a lot of funds necessary to bring the grids up to scale.
Does anyone want to come back on any of those points?
I'll have a quick go. We had a bit of a chat earlier on while we were in the lounge, and I think that the key around investment is optimized on the asset as well. So the whole idea of potentially people doing the right thing may not always be the right thing. I think going back to your point, Sarah, on are we potentially suggesting that we should have some form of land registry as to where things are going to start to get built, and then we're looking at the absorption levels from the grid there, because I think that's a sizable opportunity, because that also as well, it gives you transparency around where availability might be, which might then take a landowner and or a developer to the right place at the right time. But I'm not sure where these pockets exist. I'm not sure if they exist at all. But the key is that if we don't meet the same level of objective in terms of trying to sort it out as a problem, it just becomes another problem, and we're staring down a bigger hole at that time.
And just to echo that, John, that's a problem that we suffer. So we're trying to find generation sites to match them to industrial users, and we literally go into this blind. So we deal with an automotive manufacturer in the Northwest. We can't say, right, we know there's 4 sites in the Northwest and we're going to get those, and we could make a spreadsheet, go green and buy those. that would make our life so much easier. And it can't be difficult to do. These pockets of land are on the land registry. It's simply an API to match those up. So I totally concur with what John's saying now. That would be a game changer for us on the investment and development side.
And I think it's so interesting. A few times the term of investment has come up, because I think what we've seen the concentration be on the last few years is investor certainty for generation. That's the entire review of electricity market arrangements was based around, was how do we ensure generators' investment certainty? Now I'm starting to very quickly see quite a shift. Well, what about investment certainty for the demand side? If I'm an industrial site electrifying, how do I ensure I am going to get some kind of return on that investment beyond ESG milestones? I think it's very interesting that today Boris Johnson decided to come out in favour of locational marginal pricing, as if that's a useful part of the conversation now. But in terms of what that means of siting things closer to generation, closer to storage, co-location, semi-island at microgrids, how are these kind of thought processes starting to hopefully revolutionise our approach to security of supply?
I think we've come to a place now, at least in the States, where we realize that transmission lines that are millions of miles long, miles away from where you're trying to get power to, I mean, one storm and everybody's out. So I think everybody knows that bringing that power closer to where it's going to be used is what needs to be done. I don't know if you all have the saying here, but we have a theory in the States. It's the 96-hour theory that says that after a major power outage, it only takes 3 to 4 days for a civil order to just completely break down. And I don't know if you've seen some rowdy Americans upset, but that is something that we definitely, as power providers, that's the number one thing for us that we want to prevent. So I would say in the flexibility conversation, actually, it's not even really flexibility. It's like reliability, and then flexibility is that tool. But flexibility will never be the first priority. It's always going to be reliability. It's always going to be affordability. Then we can go into flexibility and decarbonization. I think that's the set of pressures that we're having to deal with right now. And of course, meeting the ginormous demand that's coming from AI and data centers. They're predicting 175 megawatts by 2030. Gigawatts.
Yes.
That wouldn't have been that ambitious.
Yes. You guys were like,
You had one line.
gigawatts.
You get one data center with that.
The interesting thing with data centres, and I think a lot of people miss this, especially in the UK, is the way that we pay for the transmission and distribution network is through DUS and TUS charges which go on the kilowatt hours. Now, data centres, unlike a lot of industrial companies, will not be EII. They will pay those pass-through costs. So the data centres, which get really big black eyes for what they're going to do to the grid, are actually the guys that are probably going to pay for the grid to do what all of us lot want it to do, which is support a distributed network of renewables. We work for one of our clients uses 35 gigawatt hours a year. They don't pay 1 penny in pass-through costs because they're EII. So they don't contribute to the grid at all because of government exemptions. A data centre will probably use twice that and will pay millions. So I think there needs to be a shift in all of our thinking around data centres are the enemy, because they're actually the guys that are going to invest more in the grid to help build a distributed network. Because whether it's right or wrong, that we vote for politicians who make the rules, and the rules are we pay for the grid through pass-through costs. Data centres will pay more in pass-through costs than any of us can imagine. So the person being pitched as the enemy is actually the superhero in this story for me. And I think that I totally agree with what Denise said. We need distribute. If you look at the transmission network, it's not great in this country, and I've got some stories we'll talk about later. The distribution network isn't much better, but it's better. We need to be dealing at a DNO level for localised energy. And it's at the DNO level where these data centres are really going to add value and help build a distributed network away from the centralised network that just is not fit for purpose.
I'll quickly add to that point. Actually, like Microsoft, for the data center point, they kind of got tired of waiting for us to get our grid together, and they're behind the meter.
That's what we do. We copied, I'd love to say it was my idea because I've got a massive head, but we copied the Microsoft and Amazon model and just opened the doors to UK, and everyone's fed up. So we go do as much behind the meter as we can and then top it up in front.
If I can point to a very important difference between US and Europe on this, because companies like Microsoft or Google, the big ones, big tech, they can afford to find their own solutions, which they are doing in Texas and other places, better. So they are building their own infrastructure, actually paying for it. In Europe, we don't work that way. And I think it will be also dangerous because, we have a few who can afford it, but most of our companies cannot.
We're trying to change that through funding. So I totally agree with you. So we found private funding can deal with that issue. So we've got £500 million of funding that is dealing with that issue for JLR.
Well, there might be occasions where you can have like private solutions, but we need still a concerted joint effort to make sure that all companies who need that connection.
I think, and I think the kind of public-private partnership is something that is far different, both in the UK and Europe than it is in the States. And I think in terms of spatial planning that we've kind of touched on, if a private company is saving the network money by co-locating with thermal storage, battery storage, on-site generation, then they should see some of those savings that are coming from big grid reinforcement. Do you want to come in on anything?
I agree. I would say, we really do. To your point, I don't necessarily think that it's a good thing that Microsoft is going ahead, because I think we need to create a grid that works well for everyone. And that's on us for not predicting and planning again. So I do think in an ideal situation, the grid works for everything that we're trying to put on it.
I think there's some bankable flexibility in terms of being able to do that. But the meeting of minds is between private and public potential. So I think that's the gap, and it's a big one.
I totally agree with John. Totally agree. But it's dealing with that gap.
Yeah, I think the key is that for most scenarios, there's an engineering solution. But it's along the lines of whether that actually physically works. But should it be designed before cost, or should it be a delivered system which we live with? And we try and adapt the whole process around the potential issues that have been made by the fact that not the right level of design has been put in place in the first instance, not the real understanding around where the exchanges go. I'm unsure as to where it is. I can cure it on site. So if there's a scenario that we can't send something back because of a curtailment or whatever, we can develop a microgrid. We can put some of the technology in there that does some form of storage and control. But it's adding more cost to the client because we don't necessarily understand exactly what we're doing. And to go to the DNO stuff, the DNO is kind of full to the brim with applications. There also isn't a broom by which they sweep out the old ones. So the key is along the lines of, should there be some form of reform around how those applications have gone in? Are they dead? Should they come out after 5 years? Should they be cleared off the deck? Because the availability is only there for one period of time. Someone designs a system, someone says they're going to connect it. Guess what? It doesn't happen. And that's because a private client might not get the capital, the approval, the investment that they require, and it's a dead application. But that fills up the tally for the DNO, so that there is no spare capacity anymore.
Yeah, and I think so that and I'll ask this question, and then we might go to audience questions. So think them up. On connections then, because obviously you can't go a day without seeing something in the trade press about connections. Do we think there has been, obviously the 700 plus gigawatt transmission generation queue was insane and untenable, but do we think in the 2 or so years we have spent throwing everything at connections reform and TM04 and all the rest, that has damaged the business case for demand connection reform.
Yes. Simple as that.
Absolutely.
You're trying to, again, I keep coming back to the point, this has all got to work for the end user. Because if people aren't buying the clean energy, there's no point in having clean energy. So we all know it's the right thing to do, but the economics have got to work or it isn't happening. The most important thing is you're trying to convince a guy using 4 gigawatt hours a year to move from EDF or Scottish Power, buy the energy he's bought for years and do something different. And then there's a problem. The second there's a problem, they go back to source.
Yeah.
And you're back to square one. So it's absolutely damaged it. And I don't think there's any other answer than yes.
Yeah. We don't have a lot of choices and options and opportunities to mess up. So you do it once. If the customer is upset, it's really going to damage your future opportunities. So I agree.
I think the other side of that is that the data centers are actually physically showing us that they're doing what they can do because they're modeling all their stuff on their own consumptions, their own microgrids, their own control. That's them sorted.
They're the exemplar, and they get a black eye for it. Everyone goes, "Our data centers are going to ruin the grid." I think that's a very one-sided view. I totally agree with John. They're doing more to show us the way than anybody else. And there's a reason Microsoft are worth 100 gazillion pounds. It's because they do a lot of things right. Let's copy them.
Yeah, it's primary infrastructure at the data center.
Yeah.
Absolutely.
And how are you seeing this evolve in Europe then with connections queues, especially around data centers, I suppose?
Having worked with politicians for more than 3 decades, unfortunately, there's one thing common to every political environment. There's always one focus, and then that comes sometimes, that is detrimental to the rest that needs to be done. So the generation side, the queue on the transmission side, that's of course needed to be tackled because that's what we have as a problem in the UK compared to a country where my company is based, like Netherlands, where we have more on the distribution side, massive queues. Just to give you a practical example, my company, Fastnet, we're building fast charging stations on motorways. So we sign concessions on those motorways for 12, 15, 20 years periods. And we have to wait sometimes more than 10 years to get a connection. And that's on the distribution side. So that doesn't work anymore for us. And we see that problem happening more and more everywhere. And this is going to happen here as well. So the political side, the public side cannot afford to just concentrate on one aspect, the generation side. So you need to look into all and make sure that, because it takes time. Because it takes a lot of effort.
To echo your point, we've got a site, an 8 megawatt site that we're building in Exeter, and we had a plug-in date for the end of March because the transmission network didn't tell the distribution network of a problem with Sizewell. That's now delayed it till September. So we're going back to the client, sort of cap in hand, going, "Listen, mate, there's a bit of a delay," which never goes down well. So I totally agree. It's a holistic solution that we need to build this distributed network of renewables. And if we, it goes, I don't want to say this awful business saying, so please excuse me. We can't eat the elephant one spoon at a time. We've got to gobble the old bugger down. We've got to get it in because we've got to deal with everything or we're dealing with nothing.
If I can just add, I've been to different conferences like these, and flexibility is a big topic in its context, and it's valid because it's part of the solution. But we have to be careful. Flexibility is not the solution, right? It wins us time. It frees up, more volume of energy that we can use, but it's not the solution. We need resilient, future-proof grids.
I'm going to push back on this. Any of you who know me know that I believe flexibility should be the basis and everything else should grow from that. Flexibility is not just an answer to deferring reinforcement. About a third of the savings case for demand-side flexibility comes from avoided reinforcement, from another third avoided generation capex, a bit from deferred reinforcement, and then the top bit from lower balancing costs by pushing gas off the margin. So we need, and this was kind of the point of the second question, is we need to completely upend our understanding of security of supply. A secure system is one that is provided by millions of distributed assets grids working in a diversified way rather than one transmission line that can go down in a storm, one 300 megawatt CCGT that can go off in an instant, one interconnector which has actually happened, being infiltrated by jellyfish. We can lose that, but the prospect of losing a 100 megawatt aggregated portfolio all in an instant is far lower.
I think that's a really interesting point. And this is what I seem like I'm going to be the antithesis to everything today and just being argumentative. I'm really not.
I love
but
it.
This is where I think curtailment is really important, because we all see the absolute horror stories of curtailment. But without curtailment, we wouldn't have the ability to be flexible. So sometimes the fact that we're paying for it might have other deliverables which allows us a flexible grid, which I fully believe in, by the way. But we've got to oversubscribe the energy for when it's not producing. Therefore, the investors got to be paid. And I come at this as an investor just wearing a set of energy pajamas. I want my money. That's the bottom line. And curtailment's a way that I can get that. So I do think curtailment's terrible. I think the level that we pay is terrible. But we've got to decide what hill we're going to die on. And if we want a flexible, renewable energy grid that's going to be intermittent, we either need to work out how we make batteries 10 times cheaper, which ain't happening quick, or we need to deal with some curtailment.
Or we need to encourage demand turn up.
There is that.
And making sure, I would say, curtailment for me is kind of like, I don't know, I really like the idea of things being voluntary for the customer, being forced to do it. I mean, I don't know if anybody likes to be forced to do anything. If you make the case well enough that if they're able to participate in these programs, they will get some type of benefit, whether that be savings, then I think that's our best chance. I don't know. Mandating anything when it comes to people's use of energy. I know in the States, like if you pay to have your lights on, your lights need to be on. Like no one is telling you, oh, actually from this time to this time, people will riot.
Well, the problem with the UK is that we do pay for curtailment. So Mrs. Miggins, in one hand, is paying for contracts for difference to build the renewables, and then with the other hand is paying them to be switched off.
Ooh. That's the system we've got. Yeah. And, if we're talking about a total system overhaul, that's one thing. But if we're going to build a flexible distribution network, curtailment is a part of that.
I still go back to it's great, but where's the visibility? Where are we having these conversations, and why isn't it working? So if it's not working, it's almost like there's the problem.
Yeah.
So what we should do is deconstruct that and say, right, here are the answers, because then we design schemes that are going to be fit for purpose.
This is why engineers should run the grid, not politicians.
I'm not saying that, but I'm going to go and get you a spoon in a minute for that elephant. But the key is so to use another small analogy, it's the cart before the horse.
Yeah.
And it's almost like it's glaringly obvious, but why aren't we sorting it out? I don't have the answer.
One final point on this, and then I want to bring in the audience.
Yeah. Well, curtailment, I completely agree with Denise. I mean, we cannot build our future industry without curtailment. So it needs to be done sometimes, but it needs to have its benefits. It needs to be transparent. It needs to be voluntary. And also keeping in mind that one size fits all across industries does not function. Yeah? There are industries, there are infrastructures that cannot just decide to switch off for a while because there is no energy. It doesn't work like that. A large medical center, hospital, you cannot just switch off. You can't do that. In my industry, if you drive from point A to B and you need to charge a certain part motorway, you can't just switch off and tell them just wait for another 6 hours.
But
that's more on the generation side, isn't it? We're talking about curtailing generators.
Yes.
Yes, and we're not talking about telling businesses they've got to turn their lights off. That's rationing. Curtailment saying to a wind farm, we're going to pay you to turn off because there's too much energy on the grid. So,
well, not too much energy on the grid, usually a constraint.
It's constraint, yeah. So I think that's a slightly different argument. I don't think any business should ever be told to turn off in an industrial economy, because then you're a third world country, no disrespect. But there's a difference, I think.
Misnomers around what flexibility and what flexibility is. Those myths need to be it is not curtailable connections or or forced flexibility.
No.
It's about enabling the markets and the mechanisms we have to work for industrial and commercial sites to fit their patterns. And that's what you see people like Flexitricity and Exergy 3 doing with Annandale Distillery on the B6 boundary. They have decarbonised their heat supply to make net zero whiskey by soaking up excess renewables. That's the future we need to see. Okay. Audience, do we have a roving mic?
Oh, do we have a...
Do we have someone to rove? Will I rove?
Thank you very much, guys. Very interesting panel. My name is Tanya. I'm from the company called Innova. We're an energy optimization platform. I have a question for you. In the UK, there's approximately 2 gigawatts worth of backup storage capacity and about 1.5 gigawatts of CHP backup capacity, which is currently tied, really are in the red tape, not being allowed to use it in the flexibility markets. They have to be tested every month, but not with the grid. How do you actually go around this? How do you remove the red tape? I know maybe I'm asking a lobbying advice, but what's your opinion on this? Thank you.
So should backup generation that's necessary be allowed to participate in flexibility markets? Even if it's diesel?
I think we're talking about renewable and batteries. So if we're talking about
CHP.
I think CHP is a fool's errand. It's great when gas is cheap, but then when gas goes through the roof, it's the most expensive energy. So everyone thinks CHP is great until we close the Strait of Hormuz. So I think you're going to see CHP lose its shine. But if we're talking about best backup, I think absolutely we need to change our policy around this, because otherwise we can't have a distributed renewable grid. So we've got to decide what we want. And as John said, it's why engineers should run the grid, man. It's as simple as that, because you deal with the outcome-based thinking.
I think the key is these numbers that you've just kind of given to us. Are they known? So why, again, this is back to the same question, right? We've got this stuff and we ain't using it. So why aren't we using it? The question is, why aren't we using it? It's not whether it's available or not. It's why aren't we using it? So I think
have all the answers. That
Engineers of the future, man.
It's just implementing, which is crazy, but at least we have the technology.
It doesn't matter what it is. If it's there, it's latent. Why aren't we using it?
Yeah.
Thanks so much, guys. I'm Kat Graham from Scout and Swan. We work to move data demand for high performance compute to data centers. So thanks for all the positives on the data centers. The question I had, though, is around something you said in the keynote around capacity, headroom. And that in the UK, we have 50% headroom.
Just bring the mic a little bit closer.
Sorry,
Thank you.
That we had 50% headroom and it was 40 less in the US. I'm not sure about Europe, but I haven't heard you discuss how that headroom can be used. And in terms of, I think from Denise's point around the requirement for grid operators to keep the lights on. So that stacking order you have of what's the priority, which left flexibility right at the bottom, obviously something that should be challenged. And I think it's just that ability for the grid operators to sometimes allow for the capacity to be used. But I'd really be interested in what your thoughts were around that capacity headroom and how we're using it.
How old is that capacity?
Sorry?
How old is that?
How long?
Yeah.
As in, so you're talking about capacity duration.
So where does that come from? Where can we actually go and say, right, okay, those numbers were proven at this particular date, time, stamp, and now we've moved on? Because this policy, it might be tens of years old. Which again isn't evolutionary. It's not moving on.
No, it's not. And also a lot of it comes from the, system quality security, SQSS anyway, that NESO have to model against. And then also loss of load expectation is what sets the hours of how much capacity we procure in the capacity market in the T-4 and T-1. But I think what falls under the radar there is that the way we model what capacity we need is largely based on static demand. And if they put in flexible demand into those models, it's peak demand reduction only.
Yes.
Massive.
So it's 4 to 7 p.m. and that's it. That is not the world we're moving to. It's dynamic every half hour or less so.
Massively every half. I think people miss that. The amount of times NESO nearly get demand side management wrong on a half hourly basis is shocking. And I know they do an amazing job. I don't want to bash NESO because I think they're really clever guys. But we don't realise how often we're not anywhere near 50% headroom on a half-hourly basis. We've been within 5-6% and nearly had half-hourly CNMs more often than you think. So I'm not sure on a half-hourly basis there's that much capacity. And like I said, I think really good point you made, John, is we need more visibility. We're all talking about a concept based on numbers that come from 50 different sources. So the engineering approach, it sounds like John's cheerleader, but the engineering approach that we need to take is we need data to analyse the data.
Yes, and I will add to that. One example, so Georgia Power out of Atlanta, they actually were filling out their IRP and they requested 8,200 megawatts due to data centers. They're like, we need to prepare for this. What can you give us? In return, they were given 1,400 megawatts for new gas turbines. And then 150 megawatts for demand response. So even in the situations where they are taking the time to predict how much this AI load is going to give them, we're not even equipped with the right solutions because, again, like I said, it's happening so fast and there's so much that we have to meet that people are open to, okay, decarbonization last. We need to get reliability first. We have to make sure that things are affordable first, which, again, I don't agree with, but that's the situation.
I think I'm conscious of time. I will just say I want to dispel this notion that security or reliability and decarbonisation are somehow at odds with one another. That comes back to the diversified millions of assets being security of supply. Red shirt. Oh, we cannot hear you.
Is it working? It is working.
Now.
Great panel, guys. Firstly, something is coming across really clearly. Let me see if my question pulls it out. Culture change. Okay. What is our strategy for culture change? Because you're all saying, you're quite right saying, oh, engineers should run the whole thing. Guys, engineers are running the whole thing. Okay. So there's something about, we learned an enormous amount from the Montreal Protocol when we saved the ozone layer. We had a regulation. It wasn't to do with the regulation. It was to do with Anne on our board at Loctite and our colleagues at BP. It was the people, it was the culture that were created, which cross-pollinated across a whole arena. And as I look at Greg Jackson and his kind of ticking counter octopus, where he's talking about, how much it's costing per day, not having the national grid. That gives me evidence that we've kind of broken a little bit of the culture. And I'm asking, what is your strategy as engineers? I'm an engineer as well. What is our strategy for a culture change thing that just exponentially grows the solution really quickly?
For us, it's about the economics.
I was going to say the same. Yeah.
To make a culture change, at the end of the day, we're trying to sell people energy.
Yeah.
Their main driver, and I totally agree with Denise, we're all about decarbonisation. I think we all agree with it on this panel, but people are not going to buy in unless it's saving them money on the prima facie.
Exactly.
So I think the way that we sell renewables and fixed long-term contracts to give energy stability and low-cost access to energy, the culture will change as a byproduct of deliverables.
Solid business case, solid ROI. That's what opens the door and closes it. Yeah.
I would argue a bit different. I think we need to upend the confirmation bias. As you say, engineers are running the control room now. There is a confirmation bias in our market design and management that says we think about building markets and building mechanisms around dispatchable generation. That's not the world anymore. And therefore we can't continue to lean into that confirmation bias.
I get the bankable flexibility. But I think also as well, there seems to be some calculations, some methodologies, some statutes, some rules, some regulations. Maybe we need to reconfigure those. So rather than culture, maybe re-engineer the maths behind it and make that more visible. back to visibility again, unfortunately. But the key is around these numbers. To me, don't sound right at all. If it's the numbers that are causing the caution, then we need to reconfigure those numbers. Those numbers then should release a better understanding for everyone to be able to make sure that the solutions that we deliver further down the line are the right ones.
Okay.
It's not that difficult.
No. Conscious of time, I'm going to come to our wrap-up question, but thank you for wonderful questions from the audience. This has flown by. So, in 10 words or less, what is, if magic wand thinking, what is the number one change that will make an intermittent renewable system work?
Battery economics.
Oh, can anyone beat 2 words?
It's battery economics.
I could say stop.
Yeah. For me, if we get the cost of battery, I think will come down as the EV cars come to their end. I think there's going to be a lot of cheap batteries. I think we then have the ability to make industrial scale batteries at the right levelized cost of energy, and then we can battery buffer, and we haven't got a problem. So that's my Novanik way of dealing with it.
Amazing.
Mine is similar. I would say we have to make it make sense, literally and figuratively. It has to make money. It has to make sense for the grid. All of that needs to be in place for it to.
My sentence absolutely echoes that. Stop planning flexibility, start engineering it and proving it works.
Sacrilege to someone like me. We know it works. Anyway.
For me, it will be build grids faster and use existing grids smarter, including grid enhancing technologies.
Fair.
We talked about it.
Amazing. Please join me in giving our panel a wonderful round of applause, and thank you all so much for